Today, we're finishing up the lab series, and we're going to make methyl orange. Methyl orange is an azo dye. The synthesis can be accomplished by a diazo coupling reaction between the diazonium salt of sulfanic acid and N,N-dimethylanilene. Since the coupling reaction is conducted in an acetic solution, the first product to form is protonated methyl orange, called helianthine, which is bright red. Addition of base leads to the conversion of helianthine to its sodium salt, which is methyl orange. Place the sodium carbonate in an Erlenmeyer flask and add water. Then, add sulfanic acid to the solution and heat it gently on a hot plate until it dissolves. Remove the flask from the heat. After it is cooled to room temperature, add sodium nitrate and stir the mixture with a stirring rod until most of the solid dissolves. Place the flask in an ice water bath and continue swirling or stirring until the temperature is below 10 degrees Celsius. Once the solution has completely cooled down, add concentrated hydrochloric acid to the flask. Keep the flask in the ice water bath and scratch the bottom of the flask until a fine white precipitate has formed. The solution may turn cloudy here. This precipitate is the diazonium salt of sulfanic acid. Keep it in the ice water bath for the coupling reaction. Place N,N-dimethylanilene and glacial acetic acid together in a conical vial. Use a pipette to transfer the solution to the cooled suspension of the diazonium salt in the 25 ml Erlenmeyer flask. Stir the mixture vigorously with a stirring rod. A red precipitate of helianthine should form within a few minutes. Continue to keep this mixture chilled in the ice bath for 10 minutes with periodic stirring. Obtain 10% aqueous sodium hydroxide in a small test tube. Add the entire sodium hydroxide solution slowly to the chilled mixture with thorough stirring during the entire addition. After all the sodium hydroxide solution has been added, use a glass rod to transfer a drop of the reaction mixture to a strip of pH paper to determine if the solution is basic. Add a boiling chip to the basic solution. Then, heat the solution for about 10 to 15 minutes, stirring constantly until most of the newly formed methyl orange has dissolved. Remove the solution from the heat, add sodium chloride, and allow the mixture to cool. Once the solution has reached room temperature, place the flask in an ice bath to complete the crystallization. Obtain approximately 5 milliliters of saturated sodium chloride solution in a small test tube and chill this as well, for use as a rinse solution after filtration. Collect the product by vacuum filtration using a Buchner funnel and a piece of filter paper. To complete the transfer of methyl orange to the funnel, rinse the Erlenmeyer flask with 2 ice-cold portions of saturated sodium chloride solution, and wash the filter cake of material you just collected with these rinsed solutions. In a hood, boil water in a beaker. Add the entire filter cake and filter paper. While constantly stirring the solution, continue boiling it gently for several minutes to allow the whole mass of solid to become finely dispersed so that contaminating salts can dissolve. Remove the filter paper, then remove the beaker from the hot plate and allow it to cool to room temperature. Finally, cool it in an ice bath for 10 minutes, and then collect the product by vacuum filtration. Prepare a dye bath by adding 15% sodium sulfate solution and 1 drop of concentrated sulfuric acid to water. Then add methyl orange. Heat the solution so it is almost boiling. Obtain 2 pieces of multi-fiber fabric 43. That's kind of the tongue twister. Okay. The swatch is woven such that it contains bands of some of the more common fibers used in making clothing. The fibers included are both natural fibers and synthetic. Here you will explore how the interaction of the dye with the fiber affects the color. Immerse both pieces of the fabric together in the hot bath for 5 to 10 minutes. Remove the fabric and rinse well with water. Blot the fabric with a paper towel. If the colors bleed onto the paper towel, return to the sink and rinse the fabric with more water. After rinsing and blotting, note the colorful results in your lab notebook. Take your dye bath to a hood. Make the dye bath basic by adding sodium carbonate. Then, add the bleaching agent sodium hydrosulfate until the bath becomes almost colorless. Add a little excess bleaching agent at the end. Now, take one of your dyed fabric pieces and immerse it in the bath for a few minutes. Again, rinse and blot the fabric with a paper towel. Both partners should note the results from both pieces of fabric. Now we will use a UV visible spectrophotometer to analyze the spectrum of both the protonated and deprotonated forms of methyl orange. Blot a small portion of product with filter paper to dry it so you can weigh it accordingly. Measure out approximately 5 milligrams of methyl orange. Place the methyl orange into a 10 milliliter volumetric flask and add enough deionized water to reach the 10 milliliter mark on your flask. Transfer this methyl orange solution into a clean labeled container, like an Erlenmeyer or beaker. Rinse any remaining solution from the volumetric flask into a waste beaker using DI water and rinse the flask twice more with that DI water. Your volumetric flask does not need to be dry for the next step. Using a syringe, add 1 milliliter of your more concentrated solution to the flask, then dilute to 10 milliliters with DI water. Transfer the second solution to a second clean labeled container and rinse the flask as before. Using the second solution, repeat the 1 to 10 dilution using the same procedure. Do not dispose of any of your solutions until after you've obtained the UV visible spectra. Your solution should be light yellow, which corresponds to the basic form of methyl orange. Using the UV visible spectrophotometer, scan a spectrum of the solution between 600 and 400 nanometers. Leave the spectrum on the screen. Make the solution acidic with a drop of 6 molar HCl. Look at that beautiful color change! Once again, scan the spectrum of the solution. Have the spectrophotometer overlay the two spectra so you can clearly see the differences between the two spectra. And congratulations! You have successfully finished all the labs in organic chemistry.